All right, now that we have been introduced to the periodic table and what kinds of information is provided on that periodic table, let's talk about some trends that we can see with these atoms and the way that they're arranged on that periodic table. So let's talk about periodic law. So the periodic law states that when elements are arranged in order of increasing atomic number, then elements with similar properties appear at regular intervals. Okay, so that's the reason the periodic table is arranged the way that it is. And that work was started way back when in the 1800s by Mendeleev. Mendeleev is the one who really started the work in organizing and really started the periodic table. He even left empty spaces on his periodic table for elements that they had not discovered yet, but he knew should exist based on this pattern. And then as time went on and we've developed technology so that we could discover these other elements, they did fit right along inside of his periodic table, right where he said that they would fit. So that's really cool. Okay, so let's take a look at some of these patterns that we see if we arrange them by increasing atomic number. Okay, so first we have families, and they're also called groups. So groups or families, those words are interchangeable. These are your columns. So these are the up and down columns of the periodic table. Those groups, if they are in the same column with each other, then they share similar chemical properties. Okay, so the families share chemical properties. And they have, some of them have their very own names. So what I have colored in green, these are known as the alkali metals. The blue, which is the second family, those are known as the alkaline earth metals. Yellow, which we saw in the previous lesson, transition metals. So that whole group is similar to one another. And then over here, this next to last column are known as the halogens, and then that very last column is known as the noble gases. So you may want to color code how you want to do your periodic table. What I did was I colored in those big groups with colored pencils, and then I like to highlight these groups in with highlighter to talk about their names, however you want to color code your own as you are studying. Okay, so the columns, the up and downs, are groups or families. The rows from left to right are called periods, and then these also have trends that we see. One of the trends is atomic radius. This is the overall size of the atom. So radius, just like the radius of a circle or of a sphere, it is from the center to the outer edge. That's the radius. Okay, and we see a pattern with this. We also see a pattern with first ionization energy. So what does that mean? So the ionization energy is the amount of energy required to take an electron away from an atom. Okay, and the first ionization energy means that you're starting with a neutral atom and you're removing that very first electron. We also see a pattern with the melting and the boiling point. So what are those patterns? Let's get more specific. Here is the atomic radius. Here's a graph. So if you look, okay, so we have some of these labeled. So lithium is the first element on a period, and as you can see, the radius is graphed, and as you go across the period, the radius gets smaller, and then it jumps back up. This is a new period. This is sodium. It's at the beginning of a new period, so it's nice and big, and as you go across, they get smaller and smaller to the last one. Okay, so we see the overall trend within the period is to get smaller, but as you look at those first ones, they get bigger as you go down. Okay, so radius increases as you move to the left on the periodic table, and as you go down the periodic table, they get bigger. So why is that? Why do they get larger as you move down the periodic table, as you go down the periods? This is because they possess some higher energy levels. Basically, they possess more electrons. So as you have more electrons, you have more energy levels for those electrons to reside in, and they have to get bigger as you go out. Okay, and so we have something happening called shielding. So when you have a lot of electrons, remember electrons want to get away from each other because they're both negatives. They want to get away from each other. And what happens is in the center, you also have protons, which are positive, which the electrons are attracted to, so they want to get close. But the electrons that are close to the nucleus shield those outer electrons from that positive proton center, and so it creates more space. Since they're not being drawn, they're being more deflected by those inner electrons. Okay. Why does it get smaller as you move to the right, though? As you move to the right, it's going to sort of change that connection between the protons and the electrons, because as you move to the right, you're getting more and more protons, but the ratio is not as great. And so those electrons get pulled in tighter towards those positive protons. So that's why you get smaller as you move to the right, because that ratio is changing. Okay, that first ionization energy, how much energy does it take to remove that first electron? If we look here, lithium, that's at the beginning of a period. So as you move across, that energy increases. It's going up. Okay, sodium begins the next one and it goes up. It takes more and more energy across the period. But then if you look at the ones here, these are at the ends of the period. So helium is at the end of one, neon is at the end of one, argon is at the end of one. But as they go down, they get a little bit lower each time. So your first ionization energy increases as you go up the periodic table and as you move to the right of the periodic table. So that's the exact opposite of the atomic radius. And why is that? Why is it opposite? It's because in small atoms, the electrons are really close to the nucleus. And so they have that high attraction to those protons, which makes it harder for you to take away those electrons. Okay? And you may have noticed in that graph that there's these little jumps within the group. Okay, why do you have that? That's because when you have a stable electron configuration, and we're going to learn what that means coming up soon, once they're stable, they don't want to lose electrons. Okay, they want to stay in that stable. And so it makes it harder to remove one once they reach that stable configuration. Okay, and we'll learn about those configurations and what makes a stable configuration later on in the course. Okay, the next pattern we see is melting and boiling points. So as you move towards the center of the periodic table, you're going to have increasing melting and or boiling points. So this means if it's a solid, how high of a temperature do you have to get it to melt it? If it's a liquid, how high of a temperature do you have to get it to boil? Okay, and so as you move towards the center, you're going to need higher temperatures to melt and boil those items, while further out from the center to the left or to the right, you will have lower temperatures that you need to acquire. Okay. Ionic radius. So an ion is an atom that has either extra electrons or missing electrons. So it gives it a charge. It's not neutral anymore. So there's two different types of ions. There's cations. These ones are positive. They are positive. And the way I remember that is because it has a T in it and a plus sign kind of looks like a T. I also had a student once tell me that it has the word cat in it and a plus sign kind of looks like a little cat's nose. So either way you want to remember that. Okay. Cations, they have lost electrons, so they are missing some electrons. Because of that, they get smaller. Okay, which makes sense. If you lose something, you get smaller. If you lose weight, you get smaller. So if you lose an electron, you're going to get smaller, but they're going to have a positive charge because since electrons are negative, if you lose some negative, you become positive. Then you have anions. These have a negative charge. The way I remember it is it starts with An, so it's a negative ion. That's how I remember it, if that helps you. Go ahead and steal it. So these have gained electrons. They have extra electrons. Since they have extra electrons, they get bigger. Okay, you gain weight, you get bigger. You gain electrons, you get bigger. Okay, and then since they have gained electrons, electrons are negative. They have gained negativeness, so they are negative, a negative ion. Okay, so let's do some practice. Okay, so looking in your notes and looking at your periodic table, I want you to find these two elements, Be and Ba. Find them. Look at their location. Think about the pattern that we studied with radius. Which one do you think is going to have a bigger radius, Be or Ba? The answer is Ba. And I meant to have that second one show up differently. My apologies. I didn't know they were going to come up together. So Ca or Br, take a look at those two. Look at the pattern. You should see that Ca is going to have a larger radius. All right, how about higher first ionization energy? So pause the video here and take a look and compare and see which answer goes with both of these. Out of these two comparisons, N has a higher first ionization energy than Bi, and then Ne has a higher one than Ba. All right, which one has the higher melting/boiling point? So again, pause the video, look at these two comparisons, and see which one. All right, C has a higher melting and boiling point than Li, and Cr has a higher one than Kr. Okay, all right, now which particle has a larger radius? Okay, S or S-2. That little -2 here means that it has gained 2 electrons. And then for this one, Al or Al 3+ or +3 means that it has lost 3 electrons. So looking at those patterns, pause the video and see what your answers are. Okay, S-2, it gained 2 electrons, so it's going to be bigger because it has more electrons. And then Al is going to be larger because it gained 3 electrons, so it gained those electrons.